Section 4.4, trigonometric functions of any angle theta. In the last section, we evaluated trigonometric functions of acute angles. Specifically, we drew the angle in standard position. Point P, let's identify a point P with coordinates x, y. And point P is r units from the origin on the terminal side of angle theta. All right, we can form a right triangle by drawing a line segment from the point P perpendicular to the x-axis. Let's do that. All right, and then what do we have? We have a right triangle. Note that y is the length of the side opposite angle theta, and x is the length of the side adjacent to angle theta. All right, so we can also represent angles in other quadrants. This is quadrant 1. Let's see what. All right, so let's draw an angle in standard position. All right, where theta lies in quadrant 2. Let's say that. All right, so this is theta. Again, point P. Line perpendicular to the x-axis. So this would be y, the vertical distance. This is x. All right, and of course, this would be the distance the point P is away from the origin. All right. In the third quadrant, let's just see if we construct the angle in standard position. All right, so this is theta in standard position. This is point P, perpendicular to my point P with coordinates. All right. This is the vertical distance, this is x. And of course, again, this would be r. And in the fourth quadrant, if we considered an angle theta in standard position, so theta is in standard position. If I construct that perpendicular from the point P to the x-axis, so this is my right triangle, this is y, this is x, and this would be r. So let's consider examples where we are finding the trigonometric functions of any angle theta. So that we can look at an example where we're finding the trigonometric functions of any angle theta, let's just review the definitions of the trigonometric functions. All right, so in the triangle, let's see, we have point P, Okay. So in the right triangle, we've drawn angle theta in standard position and given a point P on the terminal side of theta. We can then find the length of R. All right, so if we let R be R is the square root of x squared plus y squared. So this is the distance of R, the distance from the origin 0, 0 to the point P. All right, once we know R, you're given x and y, we can then find the values of the trigonometric functions. And these are the definitions. Just reviewing the definitions. The sine of theta is y over r. Cosine of theta is x over r. Remember we said that the cosine is the adjacent side of angle theta divided by r. In this case, the length of the hypotenuse. The hypotenuse is, in this case, is now labeled as r. The tangent of theta is the ratio of the length of the side opposite angle theta divided by the length of the side adjacent to angle theta. So tangent theta is y over x. The cosecant theta is r over y. The secant theta is going to be r divided by the length of x, and the cotangent theta is x divided by y. So now let's look at some concrete examples. All right, let's look at this example. Let the point P have the coordinates 1, -3, and this point is a point on the terminal side of angle theta. Knowing that, let's find the values of the 6 trigonometric functions. All right, so let's see. So we have the point has coordinates 1, -3. All right, so here it is. So here's my point P. So 1, -3. So if I do a perpendicular, all right, this becomes my right angle. This is now r, this is x, and this is the vertical distance y. But we know that x is equal to 1, y is equal to a -3. We need to find r. To find r, as we indicated in the definition, we know that r is equal to the square root of x squared plus y squared. So we have the square root, x squared is 1, so we have 1 squared plus y squared. Y is a -3. A -3 squared. So r is 1 plus a -3 squared is 9. 1 plus 9 is 10, so we have the square root of 10. So r is the square root of 10. Now that we know x, y, and r, we can now define the 6 trigonometric functions. All right, so let's find them. All right, and using the definitions that we stated earlier, let's get now the sine of theta. And the sine of theta is y over r. So the y coordinate is a -3. R is the square root of 10. And if you want to rationalize this, this becomes what? A -3 times the square root of 10 divided by 10. The cosine of theta is defined to be x divided by r. X is 1. R is the square root of 10. So if we rationalize this, we get 1 times the square root of 10 divided by 10. And now the tangent of theta is defined to be y divided by x. The y coordinate is a -3. The x coordinate is 1. So therefore the tangent is a -3. The cosecant of theta is defined to be r divided by y. R is the square root of 10. Y is a -3. All right, so the cosecant of theta is the square root of 10 divided by a -3. Or you can say minus the square root of t of 10, square root of 10 divided by 3, the negative. All right, cosecant, now the secant. The secant of theta is defined to be r divided by x. R is the square root of 10, x is 1. So the the secant of theta is the square root of 10. And the last trigonometric function is the cotangent of theta. The cotangent of theta is defined to be x divided by y. X is 1, y is a -3. So what do we get? A -1/3. All right, let's consider another example. In this example, we want to evaluate, if possible, the cosine function and the cosecant function at each of the following quadrantal angles. In other words, the terminal side of each of these angles lies on one of the axes, either the x-axis or the y-axis. So let's look at the first example. In this case, theta is 0 degrees. So if we look at this, all right, so theta is 0 degrees, of course. The terminal side is along the positive x-axis. And our point P has coordinates 1, 0. All right, so this is our point P, and clearly what? X is equal to 1. All right, so x is equal to 1, y is equal to 0, and of course r is 1. All right, so if we apply the definitions now, the cosine of theta, or 0 degrees, which is the same in radians, the cosine of 0. All right, and we define this to be what? The cosine is x divided by r. X is 1, r is 1, so the cosine of 0 degrees is 1. And now in part B, for the cosecant, we also want the cosecant. So find the cosine and the cosecant. So we have the cosine, let's find the cosecant. The cosecant of 0 degrees, or the cosecant of 0 radians would be, and the cosecant we define to be what? R divided by y. All right, so R is 1. The y coordinate is 0, so 1 divided by 0, of course, is what? Undefined. All right, so that's part A. In part B, the terminal side of the angle, in this case, lies along the what? The y-axis. So what do we have here? So this is 90 degrees, all right, 4 pi over 2. So point P on the terminal side would have the coordinates, what? 0, 1, all right? All right, so in this case, what? X is 0, Y is 1, and R is 1. All right, so we need the cosine, so we want the cosine of 90 degrees, all right, which is the same as the cosine of pi over 2, all right, and the cosine is defined to be x divided by r, so what do we get? X 0 divided by 1, so the cosine of 90 degrees or pi over 2 is 0. Now let's find the cosecant. The cosecant of 90 degrees, which is the same as finding the cosecant of pi over 2. And the cosecant of pi over 2, again, the cosecant is defined to be r divided by y. R in this case is 1, and the y coordinate is 1, so we have the cosecant of 90 degrees, or the cosecant of pi over 2, is 1. All right, part C and D. Here are parts C and D. I'd like for you to complete parts C and D for homework. And of course, if you have any questions, please post them to the discussion board. All right, the signs of the trigonometric functions. All right, let's review the signs of all of the trigonometric functions in each of the quadrants. Well, in quadrant 1, all of the signs of the trigonometric functions will be positive. All right, all will be positive. Let's investigate what happens in quadrant 2. In quadrant 2, sine and cosecant, because the sine deals with the y coordinate as well as the cosecant. In the second quadrant, y is positive, so the sine function and cosecant will be positive. Everything else would be negative. In quadrant 3, all right, we know that in quadrant 3, both the x and the y coordinate of any point would be negative. All right, so let's see what's positive. All right, so cosine is negative, sine is negative, but the tangent involves the quotient of x and y. So a negative divided by a negative is positive, So the tangent function is positive in quadrant 3, as well as the cotangent function. All right, so these are positive in quadrant 3. In quadrant 4, the x-coordinate is positive and y is negative. So that means that cosine involves the x-coordinate, so cosine is positive in quadrant 4, as well as what? Secant. The secant is also positive. So these are positive. Okay? All right, knowing that, let's look at an example. So you might be given an example of this sort. If the sine of theta is less than 0 and the cosine of theta is less than 0, name the quadrant in which angle theta lies. Okay, let's analyze what's going on. Well, the sine of theta is less than 0, so theta cannot lie in quadrant 1. Theta cannot lie in quadrant 2, since the sine in quadrant 2, the sine of theta, is positive in quadrant 2. So what do we have? We said that the sine of theta is less than 0. Sine of theta is less than 0. So that means what then? That theta lies in quadrant 3 or quadrant 4. All right? But we're also given that the cosine of theta is less than 0. Because quadrant 3 is now the only quadrant in which cosine is negative and the sine of theta is negative, we conclude what? Then we have to conclude that theta lies in quadrant 3. Let's consider another example. Given that the tangent of theta is a negative 1/3 and the cosine of theta is less than 0, let's find the sine of theta and the secant of theta. All right, because the tangent is negative, and y is positive, so let's see. So we got the tangent of theta is a minus 1/3, which is what? Y over x, which is 1 divided by, well, the cosine of theta, which involves x, is less than 0, so 1 over a negative 3, so x is a negative 3. So x is a negative 3, y is 1. And now, before we can determine the sine and the secant, we need what? Well, we need r. All right, we need to find r. To find r, we say that the r is the square root of x squared plus y squared. All right, so this is the square root of x is a negative 3, so that's a negative 3 squared plus y. Y is 1 squared. So what do we have here? We have the square root of 9 plus 1, which is the square root of 10. So r is the square root of 10. Now that we know x, y, and r, we can now find the sine of theta. The sine of theta the sine of theta is defined to be y divided by r. Y is 1, r is the square root of 10. All right, so the sine of theta is 1 divided by the square root of 10, which is what? You can write this, you rationalize the denominator. So we get the square root of 10 divided by 10. So that's the sine of theta. And now let's find the secant of theta. The secant of theta, secant is defined to be r divided by x. R, again, is what? The square root of 10. X is a negative 3. All right? So the secant of theta is minus the square root of 10 divided by 3. Let's define what we mean by reference angles. We will often evaluate trigonometric functions of angles greater than 90 degrees and all negative angles. These will be evaluated by making use of a positive angle, and this angle, this positive angle, is called the reference angle. So how do we get the reference angle? So we're going to let theta be a non-acute angle in standard position. So let's just notice in the first diagram, theta is a non-acute angle in standard position that lies, in this particular case, in the second quadrant. The reference angle, and we're going to call the reference angle theta prime. The reference angle of angle theta. So the reference angle theta prime is formed by beginning the initial side along the positive x-axis, as you can see here. The angle begins, the initial side is along the positive x-axis. All right? And we know that the terminal side of angle theta, all right, is here. So here's the terminal side, and it lies in quadrant 2. So if theta is between 90 degrees and 180 degrees, in other words, it's a quadrant 2 angle, we find the reference angle, theta prime, by subtracting 180 degrees minus theta. So the reference angle is this angle. It's formed by the x-axis, is the x-axis, and the terminal side of the angle theta. So to get this part here, it's just a matter of what? This is 180 minus theta. So that will give us the measure of theta prime if theta lies in quadrant 2. Now if theta lies in quadrant 3, so the first thing we want to do is to draw the angle theta in standard position. So theta has been drawn in standard position. The terminal side of angle theta is in the third quadrant. So to get the measure of theta prime, theta, the reference angle, is going to be the measure of theta minus 180 degrees. It is the reference angle that is always formed by what? The terminal side of angle theta and the x-axis. So that would be this angle here, theta prime. to get the measure of theta prime, that's going to be theta minus 180 degrees. That is if theta lies in the third quadrant. If theta lies in the fourth quadrant, so again, the first thing you want to do is to draw the angle theta in standard position. All right, so theta measures between 270 degrees and 360. In other words, it lies in quadrant 4. To find the reference angle of angle theta, we're going to subtract 360 degrees minus theta, and that would give us the measure of this angle, which is theta prime, the reference angle. Okay, let's find the reference angle theta prime for each of the following angles. So let's, given that angle theta measures 210 degrees. Because 210 degrees lies between 180 degrees and 270 degrees, theta is in the third quadrant. Okay? So the reference angle, so let's see, what do we have? All right, so here is theta, which is 210 degrees. It's in the second quadrant. All right, so this would be theta prime, the reference angle. So since it is in the third quadrant, to find theta prime, this is going to be 210 degrees minus 180 degrees, which is 30 degrees. So the reference angle for an angle that measures 210 degrees is 30 degrees. In part B, let's find a reference angle for 7 over pi. All right, the next angle is theta is given to be 7 pi over 4. All right, but because 7 pi over 4 is between 3 pi over 2, 3 pi over 2 is 6 pi over 4, and 2 pi. So 7 pi over 4 lies in the fourth quadrant. It's between 6 pi over 4 and 8 pi over 4. All right, so it's clearly a fourth quadrant angle. So the reference angle, theta prime, is going to be 2 pi minus 7 pi over 4. 2 pi is 8 pi over 4 minus 7 pi over 4. So the reference angle is pi over 4. I'd like for you to complete parts C and D for homework. The first person to post the correct solution to the discussion board will be given extra credit. This homework is due by April 5th. Now we would like to consider finding the reference angle for angles greater than 360 degrees, or 2 pi, or less than a negative 360 degrees, or negative 2 pi. So let's look at the first example. Part A, theta is given to be 665 degrees. So the first thing we want to do is to find a positive coterminal angle for 665. All right, so a positive coterminal angle, and you remember how we find coterminal angles, we're adding or subtracting multiples of 360 degrees. So in this case, I want a positive coterminal angle. So what do we have here? Minus 360 degrees. So we get that theta is 305 degrees. So the angle that measures 305 degrees is coterminal with the given angle 665 degrees. So theta, the coterminal angle 305 degrees, theta lies where? It is in 305 degrees is in quadrant 4. So now we need to find a reference angle for theta. All right, since theta is in quadrant 4, the reference angle can be found by what? Subtracting theta from 360 degrees. So that's 360 minus 305 degrees, which is 55 degrees. So the reference angle is 55 degrees. We always want the reference angle to be equal to a first quadrant acute angle. In all of these instances, the reference angle is an acute angle. In part B, theta is 15 pi over 4, and we need to find a reference angle. Again, the first thing to do, let's find a coterminal, a positive coterminal angle with 15 pi over 4. All right? So to get a positive coterminal angle for 15 pi over 4, we're going to subtract 2 pi. All right? So if I subtract 2 pi, I get 15 pi over 4 minus 2 pi is 8 pi over 4. And now if I subtract, this is going to be 7 pi over 4. All right, so we have a coterminal angle for 15 pi over 4, which is 7 pi over 4. All right, so let's say that theta is 7 pi over 4. All right, where's 7 pi over 4? 7 pi over 4 lies in quadrant 4. So to find the reference angle for theta, theta prime is going to what we need to do. Well, we need to subtract theta from 2 pi. So this is 2 pi minus 7 pi over 4. 2 pi is 8 pi over 2. Mistake. Two pi is 8 pi divided by 4 minus 7 pi over 4. 8 pi over 4 minus 7 pi over 4 is pi over 4. So the reference angle for 15 pi over 4 is pi over 4. There's one more, part C. But I'd like for you to complete part C. Complete part C for homework, and again, the first person to post the correct solution will be given extra credit. So you're to post your solution on the discussion board. This homework is due by April 5th. In this example, we want to use the reference angle to find the exact value of the trigonometric function of a given angle. So in part A, we want to use the reference angle to find the value of the sine of 300 degrees. So the first step, step 1, let's find the reference angle. 300 degrees lies where? In the fourth quadrant. So to get the reference angle, this is going to be 360 degrees minus 300 degrees. So the reference angle is 60 degrees. All right? So the sine of 60 degrees, as you may recall, is the square root of 3 over 2. All right? Because the sine is negative in the fourth quadrant, we have that the sine of 300 degrees is equal to minus the sine of 60 degrees, which is minus the square root of 3 over 2. So the sine of 300 degrees is a negative square root of 3 over 2. Let's do one more example here. Tangent of 5 pi over 4. Now 5 pi over 4. 5 pi over 4 is where? It's in the third quadrant. So let's find a reference angle theta prime for 5 pi over 4. 5 pi over 4 is in the third quadrant. So the reference angle would be 5 pi over 4 minus pi. So what do we have? 5 pi over 4 minus pi is 4 pi over 4. 5 pi over 4 minus 5 pi over 4 is pi over 4. All right. So the tangent, all right, so the tangent of 5 pi over 4 is going to be the same as the tangent of pi over 4, the reference angle. The tangent of pi over 4, as you may recall, is 1. Part C. Well, I would like for you to complete part C of this problem for homework. The first person to post the correct solution on the discussion board will be given extra credit. And this homework is due by April 5th.